So where are my documents? Could be here. No, I'm not so sure. I'm quite sure that it was here. Oh, yeah, here they are. Perfect. How is it? It's incredible. Of course. Damn it. I can't recognize my handwriting. Pablo. Is this my signature? It's so stressful. It's so hard. What is this? Digitalisation? It's too hard to pronounce. Let's try. Wow! So clear, so bright, so solid. This is a good document data. Digital. Now this sounds good.
Following on from that introduction, I'm delighted to present to you our digital transformation solution for pharmaceutical universal exports on behalf of Team 6, the Digi-engineers. To summarize the key points of the problem statement, pharmaceutical universal exports are responding to their competition reducing prices while maintaining the same high-quality standards. Furthermore, their current operating practices are heavily reliant on a paper-based system. In response, the proposal is to prioritize a digital transformation to achieve their 2021 business targets. The digitalization process will have the following key advantages: creating the potential to transition to automated control systems and practices, implementing advanced analytics capabilities, and eventually move to continuous process verification. Collectively, these advantages will increase pharmaceutical universal exports' productivity and profitability. However, undergoing digitalization in 2021 presents its challenges. It will be impossible for the team to work on site as a consequence of COVID-19 restrictions. Furthermore, due to resource limitations, the budget is limited to €100,000. Additionally, it will not be possible to upgrade machines or the manufacturing execution system, nor implement any change that will require interrupting the current production schedule. In light of this, our team virtually came together for a brainstorming session to discuss our approach to the problem. We broke the problem down into several key components. Firstly, we will undertake a literature search to benchmark current solutions and then analyze current operating practices. This will allow us to formulate an initial solution, which we will then refine taking into account GMP standards and data integrity principles. From there, we can develop our plan for implementation and analyze the economic feasibility of our solution. To expand further upon our analysis of current operating practices, we decided to use the production of OSD forms as a basis for our understanding of the process. We focused on the wet granulation method to be as comprehensive as possible. From this, we were able to identify the typical machines, critical process parameters, in-process controls and quality control factors, and hence summarize the type of data that will be generated and the data that is critical for production. In light of this analysis, we have proposed a three-step solution. Step 1 is providing operators with a tablet loaded with the Batch Manufacturing Record 4.0 software. This software encompasses all the data previously recorded in batch manufacturing records and logbooks. It is designed to be in line with Industry 4.0 principles, hence the name. All personnel will have a unique user ID with associated password protection and biometric two-factor verification. The new and improved batch manufacturing record will comprise all of the relevant manufacturing data, namely critical process parameters and in-process controls. Furthermore, it will encompass quality control data, environmental conditions such as temperature and pressure of the production environment, as well as relevant cleaning data. Step 2 is collating all the data from the batch manufacturing 4.0 records into a big data repository. From there, the benefits will already be evident. Namely, readily available data will significantly simplify preparation for reporting processes and regulatory approval. Furthermore, at this point, the data can be used with machine learning capabilities to optimize process parameters and analyze trends. Step 3 addresses the future capabilities provided by digitalization that cannot, however, be implemented directly due to the restrictions previously outlined. These include using the results of the machine learning analysis to create plans to optimize the process and plant, implementing automation, and eventually transitioning towards continuous process verification. So how exactly are we proposing to digitalize the data? As a result of our analysis, we were able to classify the machines from not at all digital to already digitalized. From there, we created a 4-point priority plan for digitalization. Firstly, incorporating data that is already digitalized from the MES. Importantly, this will not require any modification of the MES resulting in delayed production. Secondly, getting operators used to typing data directly into the tablet rather than writing it down. Thirdly, in any situation where data is unable to be recuperated directly from the machine and instead printed out, for example, we have assumed this is the case with thermal printouts, the software will have the capacity to scan the printout and then autofill the batch record. This can also be extended to take into account scans of analog displays if necessary. For all new scans, the raw image will be saved alongside the data for integrity purposes. Finally, if there are any situations where data is still handwritten, the software will be able to scan and convert handwriting. To further enable the tablet's functionality, the PID and machine diagrams will be digitalized and enhanced to incorporate cleaning information and machine status. Linked to each machine will also be key cleaning data such as date, time, and last product manufactured. This diagram will not replace manual signage, rather collate the data in a format where it can be analysed in the future. Looking now at the economic feasibility of our solution. We have prepared a budget that places the proposed solution cost in the 60 to 80,000 euro range. This is ideal as the risk of exceeding 100,000 euros is low, even if unforeseen additional costs do arise. We have identified the training of the scanning software as the most costly area, as this will be very labour-intensive and time-consuming. Indicative quotes were sourced to budget for the network, data storage, and implementation costs. To comply with GMP requirements, the proposed system must have data that is ALCOA compliant, attributable, legible, contemporaneous, original, and accurate. The data must also be complete, consistent, enduring, and available. To achieve this, we have developed a strategy involving authentication of data and involved employees, secure storage and archiving, including protection against disasters or damage, robust backup systems, defense against cyber threats in line with a Poka-yoke strategy, messages for fast, secure, and easy data access, raising employees and facility members' awareness of cyber threats. The software will importantly not allow changes to be made to original data, although modifications will be recorded. In the future, the use of a blockchain strategy can also be considered due to many advantages this technology offers with respect to the challenges faced in digitalization. Our proposed implementation strategy has 3 phases. The timeline will start in Q1 2021 and progress through the training and ongoing verification phases. Phase 1 relies on the principles of Agile Development. At least the first iteration of this loop is proposed to be undertaken during Q1 this year. Key points of this phase include identifying a project champion, agreeing on a project charter and conception of operations document, As early as possible, consultation will begin to engage the external software or hardware supplier. Furthermore, it will be communicated to customers that the company is undergoing a digitalization process, noting that this is just to keep them informed and it will not affect production schedules. Phase 2 encompasses the training of the software and training of operators. Previous production data and batch records will be used to train the software. This will be particularly important in training the software to recognize operators' handwriting. All facets of the digitalized system will be tested, from data gathering to storage and linkage of data. Most importantly, at this point, we can check that all the stored documents are legible and understandable. Operators will be provided with new standard operating procedures for the upgraded system. They will be tested on their understanding with a brief multiple choice test. There will also be virtual lessons to cover the overall project goals and tablet training. Time will be dedicated to Q&As and feedback. As soon as possible, there will be a small group on-the-job training with the tablets for the operators. Feedback from this phase will be used to implement further improvements to the system. The operational qualification phase is the ongoing verification of the digitalized system. Its performance will be checked against KPIs. Errors in data recording will be reported and a statistical analysis will be performed to inform a risk analysis of the system. From this, a corrective and preventative action plan can be devised. Furthermore, there will be ongoing monitoring of the impact on the operator's work, with feedback interviews addressing difficulties encountered, confidence, and suggested improvements. This information will be supplemented with feedback from a meeting with the head of each department. Finally, a software and hardware schedule will be finalized. The Digi-engineers team thanks you for your attention and consideration of this proposed solution. We look forward to the chance of providing you with more detailed information about our digital transformation system in the pitch next week.